Okay, y'all, today is one of my favorite days. Quadratic formula. It's going to change your life. It's going to make everything so much easier for you when you're working with quadratics. So the quadratic formula works every time. You will always find the solutions, whether they are real or imaginary, whether they are fractions, whether they are radicals, you will always be able to find them. So you won't have that problem where you try to factor and you're like, I have no idea how to do this because I can't think of two numbers that work. Now you have the quadratic formula. So the quadratic formula has a little song that goes with it. And normally I tell my kids to put their phones away. No one can record. No one can hear me sing. But I'm going to sing this song. I'm not going to try, so don't make fun of me later if you think that it sounded awful. It's just so y'all get the melody down, just so you can remember it. I learned this in, I think, 9th grade. Shout out to Miss Bartlett in my high school. And it has always worked. It has always come back to my memory because of this. So that was the longest intro in the world. Let's get started with the video. So if a quadratic function or equation is in standard form and equals 0, so it's got to look like the form ax squared plus bx plus c, so everything on the left and then 0 on the right. Then the solutions, the roots, the x-intercepts, remember those are all the same thing, are x equals negative b plus or minus the square root b squared minus 4ac, and then that's all over 2a. So it looks like a lot to remember, but right here, this is the discriminant. So remember when we used the discriminant, we could tell how many and what type of solution, and that's because it goes into the quadratic formula, which gives us the solutions. So the little song to remember the quadratic formula. Again, normally I would have the students in the classroom sing it after me, and we all have a great laugh because we're terrible singers. But I'm just going to sing the little melody so y'all can get it in your head. So it's like the Jack in the Box theme, you know, when you wind up the Jack in the Box and then Pop Goes the Weasel. It's the Pop Goes the Weasel song. So x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. Simple. It's Pop Goes the Weasel. So I'm going to do it again. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So if you need to rewind that and sing along, then go ahead. So we're going to jump right into the examples. So on example 1, we have x squared plus 10x plus 3 is equal to 0. So we need to first check, is this in standard form? Is everything on the left and does it equal 0? Yes. So then we're going to write out what A, B, and C are. So remember in the other videos when we only needed A and B for the vertex and the axis of symmetry, but I was always writing out what C was as well. That's because we need it for this quadratic formula. So A is 1. I don't see the coefficient for the x squared. B is 10. And C is 3. And then I'm just going to plug them into the quadratic formula. X equals negative b plus or minus the square root of b squared, so 10 squared minus 4 times a times c. So that's all underneath the square root. And then everything under 2 times a. So I think the biggest mistake that we make sometimes in the quadratic formula is not including the negative b under the square, on top of the fraction. Make sure that everything is over 2a. And then we're just going to simplify as we go. So negative 10 plus or minus. We have 100 minus 12, which is 88, I believe. Yeah. We have 88 underneath the square root, and everything over 2. And then whenever we have those radicals, we're going to simplify the radical. So 88 is 8 times 11, which is 2 times 4 times 11, which is 2 times 2 times 2 times 11. So we have a 2, a 2, a 2, and 11. If you use the menu number factor on the calculator, you would get 2 to the third times 11. So we're going to pull out any pairs. So we have negative 10 plus or minus 2 square root 22 all over 2. Oh. And then if we can reduce the fraction, then we will. And I see that negative 10 is divisible by 2, 2 is divisible by 2, and we have that 2 on the bottom. So we're going to reduce everything by 2. Now be careful when you reduce by any number that you're only doing front numbers. So like not inside the radical, that stays the same, but the outside is the one that's going to be divided. So now we have negative 5 plus or minus the square root of 22. I cannot reduce anything any further, so then that is my answer. So then we'll move to example 2. We need this to be in standard form, and I see that it's not. I want to move this to the other side. So I'm going to add 10. I get 4x squared minus 20x plus 25 equals 0. Now I have it in standard form, and I need to write out what my coefficients are. So a is 4, b is negative 20, and c is 25. So x equals negative b. So change the sign on b, plus or minus the square root of b squared. So negative 20 squared minus 4 times a times c. And that's all over 2 times a. So then we have 20 plus or minus, and you can put everything underneath the radical in the calculator, just as it is. So negative 20 squared minus 4 parentheses 4 parentheses 25, and I get 0. And then on bottom there we have 2 times 4, which is 8. Remember, when the discriminant was 0, that meant we had one repeated root. So the square root of 0 is 0. So now we have 20 divided by 8, which we can reduce. It's going to be a fraction. Reduce them both by 4. We get 5 over 2. So then x equals 5 over 2. So we see that when we use the discriminant to determine how many roots we have, it works. We had a discriminant of 0, the part underneath the radical was 0, and we only ended up with one answer because that plus or minus goes away. Now let's look at example 3. Remember, we got to be in standard form, so I need to get everything to the left and make it equal 0. So I'm going to move this 6x to the other side. My computer wants me to restart. So I'm going to move that 6x by subtracting it. So x squared minus 6x minus 11 is equal to 0. Now everything's on the left, we equal 0. So I'm going to write out what a, b, and c are. A is 1, b is negative 6, and c is negative 11. And now I'm going to use the quadratic formula. So x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. See? We didn't even have to scroll up to see the quadratic formula. So I'm going to simplify what's on the inside of the radical, the discriminant. We have, I think I forgot to square it. B squared minus 4 times A times C and then over 2. So I'm going to simplify that radical. 80 is 2 times 40, which is 2 times 20, which is 5 times 4, which is 2 times 2. So 2, 2, 5, 2, and 2. So if you use many number factor, you would get that 80 equals 2 to the 4th times 5. So I'm going to take out 2 pairs of 2's and leave the 4 in there, excuse me. Okay, sorry about that. 80 would be 2 to the 4th times 5, so we're taking out 2 pairs of 2's, leaving that 5 on the inside. So we've got 6 plus or minus 2 pairs of 2's would be 2 times 2, so 4. Square root of 5. And then on the bottom there we have 2 still. 6 and 4 and 2 are all divisible by 2, so I'm going to divide those numbers by 2. So I get 3 plus or minus. Remember that we're not going to divide on the inside of the radical, just on the outside. So 3 plus or minus 2 root 5. And then that's all reduced, so that is my answer. Simplifying radicals is a topic that is taught in Algebra 1, but I'm going to post a refresher video on simplifying radicals if you need it. Just that way you're not getting too confused on those radical parts, just because it should be something that is rather simple, but I know that it's been a while since you've done it. So then the last example, number 4, we need to make sure we are in standard form. Everything to the left equals 0. So we are in standard form. My next step is to write out what all of my coefficients are. So A is -3, looks like an O. B is +4, and C is -4. So remember to take those signs with you when you're writing out the coefficients. And then we're going to find our solution. So x is equal to -b plus or minus the square root b squared minus 4ac all over 2a. Didn't even have to look at the formula on the top there. So again, we're going to simplify what's on the inside. So 4 squared minus 4 times -3 times -4. So something that I say often in my classroom when we have things like all of this underneath the radical is don't be a hero. So don't try to do all that in your head. Don't think, well, I'm going to do 16 minus 12 times -4. Don't try to do that, because then you're going to make minor mistakes when you have a calculator at your disposal, because you can do this on any calculator. If you're at home, you can just open up the internet, type that in, or you can use the calculator on your phone. You have calculators available to you for small minor things like that. So don't think that you need to be a hero and do it all in your head, because again, you are going to make minor mistakes. It happens. So just use what you have available to you. So now we have to do this negative 32, and that's an issue. I don't know if you remember this, but whenever there's a negative underneath the radical, we're taking out an I. So we're going to have an imaginary root, which we knew from the discriminant. So here we're going to do 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So 2 5 times, so 32 is 2 to the 5th. So when we simplify that, we're going to take out, we're going to take out 2 pairs of 2's and then leave 1 2 on the inside there. So x equals negative 4 plus or minus 4, we're taking out 2 pairs of 2's, I for the negative, square root, and we're leaving a 2 in there. And then underneath we still have a negative 6. So I have 4, 4, and 6, so the greatest thing that I can divide them all by to simplify is a 2. So I'm going to reduce this entire thing by 2. So x equals negative 2 plus or minus 2i. Remember, we don't simplify on the inside of the radical, so still square root of 2 over negative 3. And we can reduce by a negative since the bottom and the top are negative and we have a plus or minus in there. So x would equal 2 plus or minus 2i square root 2 over 3. And that's my final answer. So again, there will be a video posted for simplifying radicals, so that way you can get that extra help if you need it, since that is a review from Algebra 1, and it has been a while since you've been in Algebra 1. So then you will do the quadratic formula homework on the next page. I'll probably only post answers to 2 of them, since there is only 6 problems for you to do. So make sure you get that done, completed, and turned in. And then I will see you all tomorrow.